Welcome back to the Science Hub SKB. Working Like a Scientist, Part 7. Here are the learning objectives. What is a lab report? Understanding and viewing the layout of a lab report, representing data, variables recap, parts of a graph, plotting data on a graph, and representing data and results. What is a lab report? Scientists not only plan and design experiments, but they also execute them. Experiments that have been carried out or executed are then written up as a lab report containing experimentally determined data. The lab report is a little different from the plan and design lab. The experimentally determined data can be used to compare with other data or prove your accepted data is true. The layout for a typical lab report. Lab reports are similar to plan and design write-ups, except that they also include spaces for equations, a method written in the past tense since the experiment has already been done, observations, results with figures, tables, or graphs, calculations if any, a discussion, a reflection, and a conclusion. Example of a lab report. Here we have a lab report on density. Pause the video to view, read, and observe carefully. Take special notice of the tense. The method must be in the past tense since the experiment has already been completed. The results. The results contain the actual figures obtained from measuring instruments and any calculations. The discussion defines and explains the main topic of the aim. Results are compared with accepted literature values or expected results. The limitations list factors that could have weakened or interfered with the results, while the precautions list steps taken to ensure safety and accuracy. The reflection connects the experiment to real-world applications and shows understanding, while the conclusion directly answers the aim of the experiment. Please note, all parts of the lab report, except the reflection, must not use personal pronouns such as I, my, we, our, your, he, she, him, or her. The report must be written in an objective, formal style as an account of what happened. Alright, here's some possible activities that you can do if time permits. 1. Try to execute and write up a lab report on osmosis. Or 2. Execute and write up a lab report on how temperature affects the rate of reaction of yeast. Representing data. Data can be represented visually. In lab reports, charts, graphs, and/or tables are used to make complex data easier to understand. Let's look at the first graph. Marine world visit, marine creatures seen. This is an example of a bar chart. So we want to answer the questions by looking at the graph. Which animal was in the least amount? Which animal was in the greatest amount? How many more crustaceans were there than reptiles? Approximately how many mammals were there? And how many mollusks were at Marine World? Did you get them right? Great! The animal that was in the least amount were the reptiles. The animal that was in the greatest amount were the fish. The difference between the crustaceans and the reptiles were 60 more. Approximately how many mammals were there? 50. There were 50 mammals. As you can see, it's between the 40 and the 60 mark. So between that is the halfway mark. It was 50. So how many mollusks were at Marine World? And we have 60 mollusks. Here's the other graph based on a student's survey about favorite fruits. This again is an example of a bar chart. Here are the questions. Which fruit was in the least amount? Which fruit was in the greatest amount? How many more bananas were there than apples? Approximately how many oranges were there? And how many more grapes were there than apples? So pause the video, Look at the graph, examine the graph, and then try to answer the questions. Which fruit was in the least amount? Mangoes. And the fruit that was in the greatest amount were the bananas. The difference between the bananas and the apples was that there were 40 more bananas than apples. Approximately 50 oranges were there because it fell midway between the 40 and 60 marks. And there were 80 grapes according to the graph, and there were 60 apples, so there were 20 more grapes than apples. Great job if you got everything correct. Presenting results or data. Graphs are useful for presenting numerical results. It is plotted on special paper referred to as graph paper. Graphs communicate information more effectively than tables because they make it easy to see how the independent variable, which goes on the x-axis, and the dependent variable, which goes on the y-axis, of an experiment are related. Now let's remember that the independent variable is often referred to as a manipulated variable or the variable that is purposely changed. This is a variable that the experimenter changes or controls to observe its effects on another variable, typically the dependent variable. The dependent variable is often referred to as the responding variable or the measured variable. It represents the outcome or effect that is observed and measured in an experiment, and it changes in response to the manipulation of the independent variable. In summary, the independent variable is the cause, while the dependent variable is the effect being measured or observed. And again, the dependent variable goes on the y-axis, which is the effect axis, and the independent variable goes on the x-axis, which is the cause axis. Parts of a graph. A graph should 1. Have an appropriate title, 2. Have labels on each axis, 3. Be properly calibrated at intervals of 2, 5, or 10, and 4. Have points that are properly plotted. Plotting data on a graph. Each point plotted has an x and a y coordinate. Let's determine the x and y coordinate for the yellow x. We see that the x coordinate for the yellow x is -4, and we see that with the arrow. We see that there with the arrow pointing to the x-axis. And the y coordinate for the yellow x is, what do you think it is? You're absolutely correct. It is 6. Let's try to complete the x and y coordinates for the rest x's. Have fun doing that. Did you get them correct? Awesome job! Presenting results or data. The table shows values for the x and y coordinates. Let's plot the points given in the table. Use a ruler to connect the points, then name the instrument that is outlined by the graph. So let's have some fun. We have a table showing x and y coordinates. We have the values for each of the coordinates. Let's have some fun plotting. So we have our graph and our first point has been plotted. So we see that we have the x coordinate of 7 and the y coordinate of 2. We have our arrows that indicate, and when the arrows now meet at a point, that is where we plot our first point. So since you have the idea now, you can try to do the purple coordinates, the pink coordinates, the yellow coordinates, the blue coordinates, and the brown coordinates. So let's have some fun. First coordinate is done. Let's do the purple coordinates now. Did you get that? Very good. Let's do the pink coordinates now. Did you get that? Very good. Let's try the yellow coordinates now. Did you get that one? Very good. Let's try the blue coordinates. Alright, did you get that? Very good. And let's try the brown coordinates. Did you get that? Awesome sauce. So now you want to connect your points. to give you the shape. And we see that we have something that looks like a funnel. Yay! So we have our title graph showing the shape of X and Y coordinates. Very good, everyone. I hope you got this figure. Okay, so now that you know how to plot points, we say that this is called a line graph, okay? And since you can plot points now, you can read the points off of these line graphs. So let's try to answer the questions that correspond to this graph that is entitled hot dogs sold per day. On the y-axis, we have number of hot dogs sold. On the x-axis, we have the days. So the questions ask, on what days were the most hot dogs sold? On what days were the least hot dogs sold? What days were the same number of hot dogs sold? How many more hot dogs were sold on Friday than on Thursday? And then we have this question here, which is where our hypothetical skills come in. So we're going to try to, make a hypothesis here. What do you think about the volume of hot dogs sold on Monday? Take your time, pause the video, answer these questions. Have fun! Alright, so the most hot dogs were sold on a Friday and the least hot dogs were sold on a Monday. And what days were the same number of hot dogs sold? We have Tuesday and Wednesday. How many hot dogs were sold on Friday than on Thursday? So we do a simple subtraction. 70 minus 50 gives us 20, because on Friday we sold 70 hot dogs and on Thursday 50 were sold, and the difference between the two will be 20. And what do you think about the volume of hot dogs sold on Monday? This answer will be very different for some person. So the response to this question would not be the same, or maybe the same. It can vary. Now, Friday may have been payday, or people don't want to cook on Fridays. So those were two options, two possible answers that could have been for this question. Here we have another example of a line graph entitled books sold per week. On the y-axis, we have number of books sold. On the x-axis, we have the week in which the books were sold. And then we have our questions on the left. Pause the video to analyze and understand the graph, and then try to answer the questions. During which week or weeks were the most books sold? During which week or weeks were 60 books sold? How many books were sold on week 8? How many books were sold during weeks 4 and 5? How many more books were sold between week 1 and 2? And give a reason why the least books were sold on week 8. Please note that the last question wants you to produce a hypothesis. It also causes you to use your scientific skills here as you analyze the graph. Do you have these questions correct? So weeks 2 and 3 are the weeks in which the most books were sold. Weeks 1 and 6 are the weeks in which 60 books were sold. Then it says how many books were sold in week 8. There were 10 books sold in week 8. I hope you got that correct. How many books were sold during weeks 4 and 5? So we find that 90 were sold in week 4 and 90 were sold in week 5. So together 180 books were sold. How many more books were sold between week 1 and 2? And we find that 60 more books were sold in week 2. Then it says give a reason why the least books were sold in week 8. And we have here the bookstore probably closed earlier, it probably experienced low stock by week 8, etc. What did you put for the last question? Alright, more graphing. And so it's this time they want you to plot this graph by yourself, and we have some guidelines here. When plotting, you should use dots or crosses. Using the values in the table, plot the following graph and find your best fit curve or line. So we have a table showing the temperature increase of water over a period of time. We have our quantities, temperature and time, and in that same cell we have the units. Okay, so make sure you put the units in one cell so that you can represent what each of these values are as we go down in each of the columns. So let's try to plot our graph. What are we given? We are given our scale. So on the y-axis there is temperature in degrees Celsius, and please note that 1 centimeter represents 10 units. And then on the x-axis we have time, which has units of minutes, and we see that 1 centimeter represents 1 unit. Okay, so let's get started with our plotting. Let's go. But wait, to figure out the value of points in between numbers, subtract the two numbers next to each other from each other. For example, you have 90 and 100, which are close together on the y-axis. Hence, 100 minus 90 will be equal to 10. Then you will divide that 10 by the number of spaces between 90 and 100. The number of spaces between 90 and 100 is 5. Okay? Therefore, 10 divided by 5 will be equal to 2. And we see that each point increases by a value of 2. So the next point after 90 would be 92. Then we keep adding 2. 94, 96, 98, 100. It's the same for here. If we subtract 0 from 10, we get 10. We have 5 spaces between 0 and 10. So 10 divided by 5 will give us 2. So the first point will be 2. The second point 4, 6, 8, then 10. We just keep adding 10, okay? So that should be easy enough. Great job. It's the same idea for the x-axis, where we have 0 and 1. 1 minus 0 is 1, divided by 5 is 0.2. So each point between there is 0.2, then 0.4, 0.6, 0.8, and then 1. Then 1.2, 1.4, 1.6, 1.8, and 2. It's the same idea. So you can go ahead and plot your graph, knowing how to determine what each space, not what each space, what each line is equal to as we plot. We have point 0. When the time is 0, the temperature is 15. So 15 must be between here. So this is 12, 14, 16. So 15 must be between 14 and 16. So equidistantly placed in the middle. So that will be our 15 mark. And then at 1 now we go up. 1 is 26, so it is in between 20 and 30. So this point is 22, 24, and then we have 26. So we're going to plot it right here, right there. That will be our next point. So go ahead and try to plot 2, 3, 4, 5, 6, 7, 8, 9, 10. And you should get this. Did you get this correct? Awesome sauce. And now all you have to do is draw your best fit curve. Awesome sauce. Did you get it? Very good. And don't forget to put your title. Graph showing the temperature increase of water over a period of time. The title of the graph is the same as the title of the table. All you do is swap out the name table and put the word graph. Great job, students. See you around for part 8.